All right, I'm going to record for you a few more gram-to-gram problems so that even after today's notes, if you need more assistance, you can watch these videos. First thing we do whenever we encounter a problem like this is to, first and foremost, balance the chemical equation. And so when I look at this balanced chemical equation, I see that we have two V's on this side, one V on this side. Not a problem, I'll just put a 2 there. That means that I have 1 Cl over here. I now have 6 Cl's over here. So I need to put a 6 right there. I have 3 H's here. Oh, excuse me. I put a 3 there because I have 6 H's on this side. And I need 6 H's on that side, and so I multiply by 3. And lo and behold, I have 6 H's, but that also gives me 3 O's there and 2 O's there for a total of 5 O's. And great, I needed 5 O's, so that's perfect. So now I'll start. Here's my lonely number, 10 grams of V2O5, so I'll put that out front. This first problem is going to be really color-coded, and after that I'll just solve the problems all in black, but I just want to demonstrate the pattern that's emerging here. So all of these grams to grams problems are going to require 3 parentheses, so you can draw those right off the bat. And I'm going to try and fill in what units will be there to help guide me. So if my lonely number is in grams of V2O5, there's only one way in the world to cancel grams of V2O5. It is with grams of V2O5. And I can only change one thing. So I'm leaving V2O5 the same, but I'm changing it to moles, because moles are the great bridge. If you can get to moles, you can get anywhere. And so, first thing I'm going to do is get to moles. If I have moles of V2O5 at the top of this problem, then I need moles of V2O5 at the bottom of this problem. Only one way to cancel moles of V2O5. Now I'm going to leave moles the same, and I'm going to start getting my way toward H2O. So I leave moles the same, but I change H2O. See how like V2O5 and V2O5 are the same there, but grams change to moles. Here, moles stay the same, but V2O5 changes to H2O. You can change one thing per parentheses. And if I have moles of H2O at the top of the last problem, I need moles of H2O at the bottom of this problem, and now I can get to the grams of H2O that I want. And I've kept H2O the same, but changed moles to grams. Okay, now filling everything in. Grams of V2O5, we'll need a periodic table for that. As I look at the problem, I see that I have 2 V's and 5 O's, so I'll need to account for all of those things in its weight, its mass. And so then I'll look to the periodic table and I'll find out where V is. No, I'll add those things together at the end, excuse me. So V is right there on the periodic table. If you were to look at a periodic table, you'd see that V is element number 23, and it weighs 51 grams. 51 is what I care about. I put 51 down there. 51 times 2 is 102. So the V's in this problem weigh 102 grams per mole. Now I have to figure out how much the O's weigh. Well, oxygen is right there on the periodic table. Oxygen is element 8 and it weighs 16, so I'll put oxygen's weight there. But I have 5 oxygens, so 16 times 5 is 80. 102 plus 80 is 182. That's how many grams per mole V2O5 weighs. So I know how many grams, and whenever it's grams and moles, it's always going to be 1 mole. Always 1 mole when it is grams and moles together. So if you look over here, I have grams and moles together, so I could even preemptively put a 1 there, knowing that because it's grams and moles, it's always going to be 1 mole. Next I have moles and moles. Whenever you have moles and moles, there's only one place you can look to get those numbers, the balanced chemical equation. And so, in front of H2O, I have a 3, so I put a 3. In front of V2O5, I have a 1, so I put a 1. Because that's moles to grams, I know that it's going to be 1 mole. It's H2O, so I have to figure out how much H2O weighs. I know that I have 2 H's and 1 O. I know I'll have to add those together. H on the periodic table, element number 1. It's got 1 proton and that's it, so it only weighs 1. So I put 1 down there. 1 times 2 is 2. Oxygen we've already looked up. It still weighs 16, so I can put 16 there. 16 times 1, just 16. Add them together, 18. That's how much H2O weighs, so I can put it for grams. And remember that it's always 1 mole whenever you have grams and moles together. And then what I'll do is I'll multiply 10 times anything on top, 10 times 3 times 18, and then I'll divide it by 182. 10 times 18 is 180, so this answer is going to be really close to 3. 2.97 grams of H2O, final answer. Okay, hopefully the color coding helped. I'm now going to solve some problems not color coding them, because otherwise it's going to be like a rainbow mess. And so our next problem tells us that we have 48 grams of HCl. That's our lonely number. It's the only number given in the problem. We know that we're going grams to grams, so it's going to be 3 steps because we want to get to grams of VOCl3. If my lonely number is grams of HCl, there's only one way to cancel grams of HCl. It's with grams of HCl. And a nice stepping stone is always moles, so I'm going to go to moles of HCl. And if you see the pattern emerging, I went from grams of VO2 to moles of, grams of V2O5 to moles of V2O5, going from grams of HCl to moles of HCl. So that same pattern will always emerge for these problems. Only way to cancel moles of HCl is with moles of HCl. And from there, I can keep moles the same, but go to VOCl3, moles of VOCl3, getting one step closer to grams. The way I cancel moles of VOCl3 is with moles of VOCl3. And then finally, I can keep VOCl3 the same and just change grams. And now I'm there. Because I need to figure out grams of HCl, I'll look to the periodic table. I have 1 Cl and 1 H in this problem. I know that I'll need to add those masses together. H weighs 1 because we've already found that. Cl is right here on the periodic table. Cl is element 17 and it weighs 35.5 grams. So multiply both those by 1, add them together. 36.5. HCl weighs 36.5 grams. Because we're doing moles to grams, it's always 1 mole. In fact, because I know that, I can just put a 1 down there because that over there is moles to grams. And whenever it's grams from the periodic table, it's always in 1 mole. All right, next we have mole to mole conversion. There's only one place to go if you're converting moles to moles, the balanced chemical equation. In front of VOCl3, I have a 2, and in front of HCl, I have a 6. Just a reminder, the 2 comes from there, the 6 comes from there. Balanced chemical equation. All right, now I need to figure out grams of VOCl3 because I've got everything else filled out except this last spot here. So what I'm going to do is figure out how much that weighs. I have V, O, and Cl in this. I have 1 V, 1 O, and 3 Cl's. V, as we determined in the previous problem, weighs 51. I only have 1, so 51. Oxygen, as we determined in the previous problem, weighs 16. And I only have 1. And chlorine, as we determined in this problem a little earlier, weighs 35, and I have 3 of them, so that's 106.5. I add all those together, and I get 173.5. So V plus O plus 3 Cl's is 173.5. I multiply all those together, 76.0 grams of VOCl3. All right. Hopefully this is a little more helpful in demystifying. Call me into your breakout room if you have questions.